Welcome back to Info Index. Today I will be teaching you how to factor simple trinomials. I will be showing 4 different factoring techniques. These techniques are common factoring, group factoring, factoring by inspection, and factoring by decomposition. First off is common factoring. To do this, you need to first determine the greatest common factor of all the terms, or the GCF, and then move that factor to the outside by dividing all the terms by that factor. Let's do an example. 5x cubed minus 15x plus 35. The greatest common factor between these terms is 5, so we move 5 to the outside. On the inside of the bracket, we have to divide all the terms by 5, so the inside becomes 5x cubed divided by 5 minus 15x divided by 5 plus 35 divided by 5, and the factored expression is equal to 5 open bracket x cubed minus 3x plus 7 close bracket. Now let's try another example. This one's a bit harder. 7x squared y squared minus 35xy cubed minus 14xy squared. The common factor can contain variables as well. To find the common variable factors, we have to find the greatest amount of each variable they share. In this case, the largest y shared is y squared, and the largest x shared is just x. The greatest common factor in this case would be 7xy squared. When we factor that out, divide all the terms by that factor, we get 7xy squared, open bracket, x minus 5y minus 2 close bracket. Note, we always try common factoring first for any of these 4 techniques. The second technique I am going to show is group factoring for equations with 4 terms. First, you can rearrange the terms in order for you to make it easier to factor. Then you split the equation into 2 parts and common factor them separately. If the factors are not the same in the 2 parts, then rearrange another way and try again. If nothing works, then it is not factorable. The first term and the third term seem to have common factors in this case, and the second and last also seem to have common factors. You might want to rearrange this so that the 2 that have the common factors are right beside each other. From the first 2 terms, we have a common factor of 7y, so we factor that out, making it 7y times 2x plus 1. From the other 2, we have a common factor of 3x, so it becomes 3x multiplied by 1 plus 2x. Since 1 plus 2x is the same as 2x plus 1, we have a common factor between the 2 groups, so we can factor out, making it become 2x plus 1 multiplied by 7y plus 3x. Now the second problem. We see that 15 and 10 share a common factor. This is a good indication that you want to group these 2 together. Then the other 2 should be grouped together as well. The first 2 terms share a factor of y squared. When we factor it out, we get y squared multiplied by 3x plus 2y. The last 2 factors become 5x multiplied by 3x plus 2y. We see that these 2 groups have 3x plus 2y in common, so we can factor that out, getting 3x plus 2y all multiplied by y squared plus 5x. The third method is factoring by inspection. We first find the 2 numbers that multiply to the first and last terms. The products of those factors need to add up to the middle term. We can use the cross method after this. Because we have a trinomial with degree 2 here, and the coefficient of the first term is 1, we know that the factored form will be x plus a number multiplied by x plus another number. The first term has a coefficient of 1, and the last term has a coefficient of 4. 4 can either be 4 multiplied by 1 or 2 multiplied by 2. We write the factors of the first term on the the left side and the last term on the right. We then multiply the numbers diagonal from each other and add them up. In this case, it is equal to the middle coefficient of 5. This means we are done, and then you pair them going from left to right. It becomes x plus 4 multiplied by x plus 1. For the second question, we see that we have a common factor of 4 in all terms. This means we can factor the 4 out. The equation becomes 4 multiplied by x squared minus 3x minus 4. We see again that the first coefficient is 1, so we can follow the same steps as the last example. 4 is equal to 4 multiplied by 1 or 2 multiplied by 2. Now we crisscross again with 1 and 1 on the left side and 4 and 1 on the right side. Since the last term is negative, one of the factors on the right need to be negative. If one way doesn't work, then put the negative on the other factor. If we put the negative on the 1, then we see that the products do not add up to negative 3. We then put it on the 4 and it works out. We can now write the factored form, which is 4 multiplied by x plus 4 multiplied by x plus 1. The last way is factoring by decomposition. We first look for two numbers that add up to the middle term and multiply to the product of the first and last terms. We list them in a table, adjust the signs if there is a negative, then rewrite the equation, splitting the middle term into ones with the two numbers we found. We then factored the first two and last two terms separately. If there are no common factors, try grouping them the other way. Finally, we can take out the common factor and complete the question. For the first question, we have to find two numbers that add up to 7 and multiply it to 2 times 3, which is 6. With add to 7 on one side and multiply to 6 on the other. We then find the pair that is the same on both sides. Which is 6 and 1. We rewrite the equation so it becomes 2x squared plus 6x plus x plus 3. When we factor the first two terms, we get 2x multiplied by x plus 3. The last two terms are already x plus 3, so we can leave it. We see here that there is a common factor of x plus 3 between the groups, so we can factor it out, making it become x plus 3 all multiplied by 2x plus 1. For the last question, we see that there is a common factor of 5 in all the terms. We can factor it out, so it becomes 5 multiplied by x squared plus 3x plus 2. Now we need to find two numbers that will add up to the middle term of 3 and multiply together to be 2. On a table, we get this. We see that 2 and 1 match up on both sides. Now we get 5 multiplied by x squared plus x plus 2x plus 2. The first two terms inside the bracket share a factor of x. Factor it out and it becomes x multiplied by x plus 1. For the last two terms, there is a common factor of 2. When we factor this out, it becomes 2 multiplied by x plus 1. We now see that x plus 1 is a common factor between the groups, so we can factor that out, leading us to the answer of x plus 1 all multiplied by x plus 2 inside the brackets. When you write the answer, don't forget to bring back the 5 we factored out in the beginning. The final result is 5 multiplied by x plus 1 multiplied by x plus 2. When you are factoring trinomials, remember to always combine the like terms so you get a trinomial before factoring. Then you should factor out the greatest common factor to make the rest of the factoring easier. Then you can decide which type of factoring you want to use. Finally, you should practice lots of factoring problems in order to get faster at them. Be sure to like and subscribe for more content.